Alright, this is a lesson on factoring, distributive property, and combining like terms, which a lot of times we think of as simplifying. Alright, this is to remind you that you need to simplify by getting all your like terms together to review what like terms are. Like terms have the same variable part to the same power. That means no variable matches no variable, so constants match constants, like a 7 and a 2, or a -5, they would all match. C's match C's, so if I had a 9C and a -3C, they could be put together. W's match W's, like we have here, except I have W's and W squareds, and those are different because they're not to the same power. So let me go through the steps to do this. We would start with leave, change, opposite. I'm going to go ahead and do that on the problem. Leave, change, opposite. Then I'm going to do the distributive property to bust them out of jail like I talk about. So that would then be 14 plus 8W plus a -5 times a 3W is a -15W squared, and a -5 times a 1 is a -5. Now I'm going to try to combine like terms. Well, here's a set of like terms. These are constants. They match because they have no variable to no power. So I'm going to use the commutative property to move them together. They have different signs, so I subtract sign of the larger, and that becomes a 9. Now some people will think that these two match. Can you see why they don't match? W's don't match W squareds. They have the same variable, but not the same power. So I would have to leave them separate. And at this point, you're done. You've simplified it. You've got it down from all of this junk that we had at the beginning to 3 terms. Terms are the math parts that are added together here. And so we have 9 as a constant term, 8W is a variable term, and -15W squared is another variable term. That means, to review, 8 is the coefficient of this one, of this variable term, -15 is the coefficient of this variable term, and 9, of course, is a constant. Alright, again, we're going to try to bust all this stuff out of jail. And remember why we're busting them out of jail, because we have some things that want to fit together. Like that 4 is a constant, and that 7 is a constant. They want to get together, but that 4, really it's a -4, is trapped inside this set of parentheses. Okay, so we want to bust it out of jail. If I were to break this down into 3 steps, the first step is leave, change, opposite. Second step is distributive property to bust things out of jail so they can get together. Step 3 is combine like terms. So find the things that match and add them together. So here's leave, change, opposite. Do that for all subtraction problems. And there's an understood 1 right there. Be careful, so I always write that in so you see it. So we've done the first step. Let's do the second step. Distributive property. 1 negative makes this negative. 2 negatives makes this positive. 1 negative makes this negative. And then don't forget the 7 that we had at the beginning. Now I'm doing the third step because we've done the second step. Combine like terms. So anything that matches I'm going to put together. So this 7 is a constant term. It matches this 12 and it matches this 12. They're all constant terms. So we can add these together. 12 and 12 is 24. Plus 7 is 31. Remember, this is why we did that work with the properties of operation. I'm doing that because I can move them around because it's all addition at this point. I've changed it all to addition, so now I'm using the commutative property to put them and group them together in the ways that I want. These two are both variable terms, but the variables don't match, so I have to leave them separate. So I have plus -6g plus -4m, and here we have a constant term, a variable term, a variable term, so we have 3 terms. You can't combine them. Nothing matches anymore. No like terms. So we're basically done simplifying at this point. To review, that's a constant. That -6 is the coefficient of that variable term, and that -4 is the coefficient of that variable term. Remember our steps: leave, change, opposite, distributive property, combine like terms. So here we go. Here's my leave, change, opposite. Be careful. This one's an easy one. This one's an easy one. This one right here, make sure you leave it outside because that -1 needs to be distributed to the entire group. Now I go to distributive property. -1 times 4, that's 1 negative, which makes it negative. Then 2 negatives, which makes it positive. I still have a -10c back here and a 3c to the 5th up here. Combine like terms. Well, I see these two match because the c's match. This one has a c in it, but it doesn't match because it's a c to a different power. So I'm going to have to leave that 3c to the 5th separate. I'm going to have to leave that -4. and then I get these together. They have different signs, so I subtract sign of the larger. And we've simplified it down to 3c to the fifth plus -4 plus -3c. Variable term, so the 3 is a coefficient of that variable term. Constant, there is no variable. Variable term, and the -3 is the coefficient of that variable term. All right, leave change opposite. Distributive property. One negative makes this one negative. One negative makes this set of w's negative. Now combine like terms. You see why some people might think these are like terms because the 18s match? That's not what we're looking for. We're looking for the variable parts matching. So this -16w and that -18w, they match. Not because they're negative, but because the variable matches and it's the same power. So I can add and use that same sign since they're both negative. Add and use that same sign. And this matches this one. They have the same sign, so we add and use that same sign. This is what you consider a two-term algebraic expression. There's your constant. This is your variable term, of which -34 is the coefficient, and w, of course, is the variable. Can't solve it unless it's equal to something or we know what w is. Now we're going to learn how to factor. Factor equals reverse the distributive property. Factor is reversing the distributive property. You've done some factoring in the past. You might have taken a number like 72 and factored it with a tree, right, where you had 2 times 36, and 36 is 2 times 18. Keep bringing down this 2, and then this 18 is 3 times 6, and then bring down that 2 and that 2, and it gets ugly, and this 6 is a 2 and a 3 and a 3 and a 2 and a 2, and we factored it down to a multiplication problem, because that's really what we're doing, is we're writing this product as a multiplication problem. I'll show that the other way that people have seen it. Maybe you want to do that with 45. I see that 3 goes in there 15 times, and 3 goes in there 5 times. That means I could write 45 as 3 times 3 times 5. That's writing it as a multiplication problem. So when we talk about factoring, we're going to be writing it as a multiplication problem. So of course, if we want to write that as a multiplication problem in the same way that we divided on those last two examples, we need to divide by something here. So I'm going to divide this by whatever 28 and 36 have in common. In fact, we're looking for the greatest common factor, which I'm not going to reteach at this point, but you might notice that a 4 goes into both those. So I'm going to divide both of those by 4. And just like the distributive property, both of those in that group are going to be divided by 4. We're used to multiplying with the distributive property, but we're going to divide, because of course we're undoing that distributive property. So 28g divided by 4 is 7g, and 36 divided by 4 is 9. And then what we do is we write what we divided out. We divided them by 4. So now you can see it's a multiplication problem. 4 times this 7g plus 9. And if we did the distributive property, watch, I'd be at 28g. I'd be at 36. I'd be right back to where we started. So we can undo the distributive property by factoring, and then we can, of course, distribute to undo that. Here I have a picture example of that. I have a rectangle that has an area of 45g and a rectangle that has an area of 18. And what you should notice is they have the same height. That means that thing is something that they multiplied, because to get the area of 45g, you took this height times this length. To get 18, you took this height times this length. Does that make sense? So what I know is this is what they have in common, is that height. So when I'm looking at 45g and 18, I see that they have a 9 in common. So I'm going to be dividing 45g plus 18 divided by 9. Again, this one gets divided by 9, and this one gets divided by 9. So I divide 45g by 9 and get 5g. I divide 18 by 9 and I get 2. Now I remind myself what I divided out. I divided out a 9. That means in this picture, the height had to be a 9 because that's what they had in common. This distance on the first rectangle was 5g, and this distance was 2. So we took 9 times 2 to get the area of 18, and we took 9 times 5g to get the area of 45g. This is what it looks like when it's factored. Hopefully by now you can spot what needs to be factored out. I'm going to divide these by their greatest common factor. So I'm looking for something that goes into both 63 and 14, like 7. So I'm going to divide this one by 7. and I get 9. Divide this one by 7, and I get 2h. And don't forget that was a minus in between there this time. And then remember what you divided out. You divided out a 7. And if you ever want to check your work after you factor, just do the distributive property and see. 7 times 9 is 63. 7 times 2h is 14h. And isn't that exactly what we started with up here at the top? 63 minus 14h. What do I need to factor out this time? I need to factor out a 2. And let me there is a 6 in there, but I'm going to go ahead and do it by 2 so you see what would happen. So let's say I just noticed the 2. So I divide this by 2 and I get 12. Divide this by 2 and I get 15m. Now, I noticed then that these still have another common factor, so I need to take something else out. I see they have another common factor of 3. So let me divide that again by 3. 12 divided by 3 is 4. 15m divided by 3 is 5m. And then I need to remember that I took out not just a 3, but a 2 and a 3, and I will need to multiply those. So if I took out a 2 and a 3, I really took out a 6. So if I went back up to that original one and divided out a 6, I'd be right to my answer of 4 and right to my answer of 5m, and we have it factored.